Okay. Hello. Hello. Good evening, Amir.
Hello, good evening, sir. My name is Mohammad Amir Khalil. I am from Samastipur, Bihar.
Hmm.
I have done my matric and 12 from home district, Samastipur, from RSB Inter High School.
Hmm.
And after that, I prepared for JEE Mains in Fitzi, Patna. And then I selected in NIT Srinagar. So I have done my electrical engineering from NIT Srinagar in 2020. After that, I placed in Tata Projects Limited, in which I posted in Mumbai Metro Line 3 package 4, Kulaba Bandra package. Mostly I was there at Siddhi Vinayak Sitla Devi and Dadar Metro Station. So after completing 1 year in Tata Project Limited, the jobs were not according to my desires that I left, and then I came Delhi to prepare for exams,
Okay. So for
competitive.
2021, you are preparing, right?
At the end of at the starting of 2020, sir, 2022,
Okay.
2022,
Okay. So
last
and
2 years.
the that project you are working, so that metro line is started or not? So have you have
No,
any
sir.
idea?
Actually, when I was there, Corona was at peak, so very tough situation at that time. Now it is going on.
Mhm.
Actually, Siddhi Vinayak metro station has completed, I think. Now its
Mhm.
work is going on at Sitla Devi and Dadar. Actually, I was there in MEP department, mechanical, electrical, and plumbing department.
Okay. So it was mixed, so it's good, right? Mechanical plus electrical. Okay.
Yeah.
Okay. Okay. Okay, Amir. So basically, so my first question is, what are the different kind of electronic switches are available?
Uh, there are different types of switches like SCRs, power MOSFET, GTO, BJT,
And what about IGBT?
yeah, IGBT also.
Okay. So for higher
Uh,
voltage,
com-
okay, for higher voltage application, which you will be prefer, means MOSFET, IGBT, or something else?
no, sir, I will prefer MOSFET.
Oh, why is there any specific reason?
Due to low conduction losses and high switching frequency, sir.
Okay. So what's about this breakdown voltage?
Which breakdown voltage?
No. So if suppose for the where the application, any application where the breakdown voltage is less, so maybe suppose we can say 200 or
Yeah,
250
yeah.
volt. Okay. Then
Actually, in a power MOSFET, there are no any secondary breakdown occurs. In BJT, there are secondary breakdown occurs.
okay. So for higher
That's why we prefer MOSFET for higher voltage.
okay, okay. No, so actually for higher voltage racing, IGBT basically prefer as compared to the MOSFET. You can means after the interview you can analyze in the detail, but for higher voltage level, IGBT is mostly preferred. Okay,
Okay, okay.
okay. And how you know about the snubber circuit? Snubber,
Sonawar
SNU.
circuit.
Huh.
Yes, sir. Yes, sir. Yes, sir. It
Mhm.
is a circuit which is generally used for the protection of SCR, and
Mhm.
it is used against dV by dt protection,
So
in which
dVdt means
resistance and capacitance rate of change of voltage with respect to time. I mean,
okay,
generally, sir, Sonawar circuit is resistance and capacitance are in parallel.
okay, 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 okay. So let's state me the Thevenin's theorem. So in case of the network theory.
Okay, okay. Sir, Thevenin theorem states that in a linear binetwork circuit, if there are two or more independent elements are there, then the whole elements can be represented into a series voltage source along with a series resistance.
Okay. And can you state me the Thevenin's theorem? Sorry. Thevenin's is okay. So what are the different advantages of that active filter over the passive filter?
Actually, sir, in digital electronics, I did not prepare very well. So
Okay.
digital,
Okay. It's fine. So your BTech is in electrical or electronics? Means
no, sir, only electrical doubly.
okay, W is the right. Okay. Okay. So in the electrical point of view, what have you heard about the per unit measurement or the per unit thing?
Yes, sir. Per unit value is defined as the actual value by base value.
Okay.
and
Why
it
we
is
use it?
unitless quantity.
Why we prefer the
Actually,
per
sir,
unit?
yeah, yeah. Actually, in power systems, sir, we prefer per unit to reduce calculations because in power system, na, we do calculations in terms of megawatt, MVA, GVA. That's why we use per unit system to convert in derived quantity, actual quantity. Actually, there are two main base quantities are there, V base and S base. And from this base, we can convert it into derived base, I base, Z base.
Okay, got it. So can you tell me difference about accuracy and precision?
Accuracy, sir, it is the measurements of repeatability and reproductivity.
Hmm. Then
No,
what is
no, sir, no.
precision?
Accuracy, it is the measurement of repeatability and reproductivity, and precision, it is how much accurate from the actual value.
Okay, so is it opposite or it's what you said is correct?
Actually, sir, I am confusing. No, once again, I am recording myself. What is the difference between accuracy and precision? Sir,
Okay, let
accuracy is then a measurement of repeatability and reproducibility done by the same observer. But in terms of precision, same thing are done by different observer.
okay. So let me consider one example. If suppose you know the archery event, that was one of the sport, right? Archery.
Archery means, sir?
That वो क्या हिंदी में बोलते हैं, जैसे वो नहीं बाण मारते हैं, अभी क्या बोल
धनुष
सकते
बाण।
हैं? हाँ, धनुष बाण वाला वो इवेंट होता है, राइट?
Okay,
आर्चरी.
okay,
Okay, हाँ. So that the maximum or the point it is 10, right? So if suppose five number of times I have hit 9.8 or near to 10, then it comes under accuracy or precision.
precision, sir.
Oh, then why not accuracy? Okay, wait. I will take one more example. If suppose my I like throw for the archer, so that for the five number of times, so every time it is exactly at nine. Means all the five time it is cracking the nine wala point. And in the other hand, suppose I again tried for the five time. So there it is like one time 9.8, 9.9, 9.7, 9.9. So what is more accurate and what is precise? What is accuracy and
Uh,
what comes under precision?
Precise will be, sir, maximum value 9.8, 9.9, I mean.
No. So basically, what happened now? So we want to target 10, right? So what is nearer
Okay,
to 10? Basically, it is the accuracy. We are going toward the what is our aim? And
okay, okay,
precision means every time we are getting the same thing, repeating thing.
okay,
Okay, so that's come under the precision.
okay, sir, understood.
Okay. So please tell me about the stepper motor.
A stepper motor,
Mm-hmm.
uh, stepper motor, actually, in stepper motor, uh, alpha is speed in stepper motor, speed into 360 motor.
Okay. So is the stepper? Uh,
Mental in a step motor. It's really generally used in printing, copy, machine.
mhm.
These are applications of.
Input pulse motor comes. Is it synchronous or asynchronous? Okay, so it's like the generator and alternator, or is it the
Mm,
same thing?
no, sir. It is not the same thing. But generally, alternator we use at the generating station side. Normally at 11 kV.
Mhm.
Alternator and generator is normally a generator which works on the principle of Faraday's laws of electromagnetic induction.
Okay, what is the difference between them in terms of their construction?
Constructions are both are same.
No. So there is slight difference. You can maybe like deeply study after this interview. Okay.
Okay, sir.
Okay. And what is the difference between the induction motor and servo motor?
Servo is also a type of induction motor, single phase induction motor.
But different.
Induction motors, there are two types, single phase and three phase. Both have different applications. A servo motor, it is
So
a simple.
in terms of inertia, what is the main difference between them? So which have the high and which have the low inertia?
A three-phase induction motor have high inertia, and servo motor have has less inertia.
Okay. 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 So can you please define the Norton's theorem?
Yes, sir. Norton's theorem states that in a linear bilateral circuit, if there are two or more independent sources, then the whole independent sources can be redundant into a current source along with equivalent resistance in parallel.
Okay. So is
And
it only
we can find
resistor or impedance or only resistor?
no, sir. In DC circuit, it is resistor, but in AC, it becomes impedance because
Mhm.
we can conclude capacitance and inductive reactance too in AC circuit.
Okay. Okay. So have you value in the your BTech? So have you plot that Bode plots in control
Yes,
system?
sir. I have plotted Bode plots in control system.
Okay. So what does that from the Bode plot? What information basically we get?
Bode plots gives information about absolute stability of the system, not relative stability of the system. We can find four different terms from Bode plot: phase crossover
Mhm.
frequency, gain crossover frequency, phase margin, gain margin.
So in that Bode plot, what is there on the x-axis or what is in the sorry, what in the x-axis and what are on the y-axis?
Yeah, sir. In Bode plot on y-axis, we plot magnitude of GH of j omega in dB, a
Mm-hmm.
decibel, and on x-axis we plot omega in terms of logarithmic. I mean
Omega
log
means
omega.
what? Speed or what?
Omega
Sorry.
means no, I mean frequency, uh,
Okay. Okay. So it's normal frequency or logarithmic?
logarithmic frequency, sir.
Okay. And on the y-axis, we only plot amplitude, right? No other thing.
Yeah, magnitude of GH of j omega in dB, magnitude. We plot magnitude, and
And
also at below angles we can plot on y-axis.
phase, you are saying.
Yeah, phase.
Yes, 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 right. And what about the oscillator? So what is that oscillator basically?
Oscillator is a device which is used only for positive feedback.
No. So basically, what oscillate creates means what oscillator creates means what is that?
Oscillator.
Huh, please explain. Or
Actually, sir, electronics part,
okay, what are the types
electronics
of
part I did
oscillator?
not prepare.
Okay, okay. And have you know about the types of
Mainly,
oscillator?
yeah, I heard about types of oscillator, LC oscillator, RC phase shift oscillator, and phase shift, yeah, RC phase shift oscillator, LC oscillator, a Charpitz oscillator, and so on.
Hmm. And how it differed? Means so basically, let me say you. So told you that oscillator basically of two type, harmonic and relaxation oscillator. So have you heard about that?
No, sir.
Okay, okay, okay. No worries. Okay. So there are again, I will ask like two to three question more. So so why in the generation point of view, the in case of the thermal power plant, so the generation voltage is only 11 to 33 kV. Not why not they generate at like higher kV values?
Yeah, sir. This is due to losses, sir. Uh,
Which type?
Copper losses. Suppose sir S बराबर V I equal to S by V. So I is inversely proportional to V. So if I will take more voltage, I will take
Mhm.
less voltage, then current will be more. So I square loss will be more. That's why, yeah, I square R losses, copper losses. That's
Mhm.
why we prefer to generate voltage at 11 kV. And
Mhm.
one more thing is form factor.
Okay. So in case of the distribution line, where the lighting arrestor are placed?
Nearest the transformer, sir. A secondary distribution transformer.
Okay. So this is my second last question basically. So mention the different method that are used to start the induction motor.
Sir, can you repeat? Your voice was breaking.
Okay. So can you please explain or tell me what are the different methods that are used to start the induction motor?
So starting of induction
Hmm.
motor, there are generally two to three methods are used for starting of three-phase induction motor. First is direct online starter method, and second auto transformer starter method, and third star delta starter method.
Okay. So have you heard about the resistance starter or the series reactor start?
Yeah. This is
Okay.
also. I actually left.
Okay. So this is the last question from my side. What is the inrush current?
Inrush current is a magnetizing current, which is used. I mean, due to inrush current, the magnetizing curve becomes like this.
Okay, so I will give you one example. So at my home when I want to on any light or fan, then if suppose I turn on that light or fan by using the switch on the any button, so at what particular time this inrush current basically comes into the system?
Initially between the 2 to 5 millisecond
Okay, so
at
at
the
starting
starting
or
of two
at.
to five. No, at the starting of 2 to 5 millisecond.
So is it only in case of AC or DC or both? Like what?
No, sir, only AC.
Oh, so if my current is DC, then it should not be there, right?
Yes, sir.
Oh no. Basically, in case of both AC and DC, it is there.
Okay.
Okay. And it is only applicable for high voltage or high voltage, or in case of low voltage, like at our household, it is also there. So what's your opinion?
Okay.
No. So I am asking you a question basically. So this inrush currents come in case of only high voltage system or high voltage instrument, or in case of the low voltage supply also it is there.
No, sir, for high voltage only.
Oh, then why, if suppose in low voltage I starting my switch or any application, why in the starting this large current not flow? Why it is not applicable, or in case of the low supply voltage?
No idea, sir.
Okay, so basically when we operate any instrument, so when we initially powered it, so for the first time that you mentioned 3 to 5 millisecond, so in case of any AC or DC, that particular high amount of current is there. So that is the inertia current
Okay.
basically.
Okay, sir.
Okay
Okay.
then. That's
Okay. Uh, so, sir, we can provide him feedback. You can provide him feedback. I think so. He needs to brush up the knowledge, right? Some.
yes. So you know about the most of the thing, but slightly you are missing. So maybe you
Yes, sir, I
continue
know, I
to
know.
revise once.
Actually, today is my first mock. Today is the first mock,
And you
and
got nervous again.
I did not prepare well. मतलब बहुत सारे सब्जेक्ट मैंने अभी रिवीजन नहीं किया सर अच्छा से.
Hmm.
That's why मैं थोड़ा रिकॉल नहीं कर पा रहा था.
Right.
I have to work on this in next 10 days.
ओके, आराम से करिए. वैसे भी इंटरव्यूज के भी डेट आने के हैं, है ना? बट
Yes, sir.
बट आपको लगभग आंसर पता थे. थोड़े थोड़े कहीं पे आप मिस कर गए, तो मुझे लगता है रिवीजन करिएगा तो आपका हो जाएगा. ओके, यू आर ऑल्सो द राइट कैंडिडेट. फिट हो आप एचपीसीएल के लिए, बट थोड़ा ना कहीं बस रिवीजन पे फोकस करिएगा एंड जीडी जीटी पे फोकस करिए, जीटी पे फोकस करिएगा. ओके, तो मजा आया
Yes, sir.